I've never seen a two-column proof multiple choice question before.
Let's see if I can find it in these documents here. Oh boy, that may be easier said than done. Let's see. That's not it. Let me just click real quick on it. Here it is.
This is a pretty good one. And in fact, this is a pretty good type problem. This makes two-column proofs far easier to me to do. Have you seen anything like this where they give you a two-column proof and they fill in the blanks, and in other words, question 22 is a multiple choice and you have to pick which is the correct answer? Okay. So good practice? Yeah, I think it is actually. So we're given that E bisects BD and that angle B is equal to angle D.
Okay.
We're trying to prove that AB is congruent to CD. So if we're trying to prove AB is congruent to CD, at some point we're going to have to prove what?
A, B, C, D, that they are parallel?
Good guess, but these two triangles are congruent. We're going to have to prove they're congruent. Okay? So let's look at their two-column proof. So 1 is the given, 2 is the given. 3 says BE is equal to DE. Why? Why is the reason for that? It's one of these 5 answers. And ignore what's circled. My student didn't know how to do these, so that's not necessarily the answer.
For reason 3, BE equals DE.
You can go ahead.
Equals DE.
Yeah, go ahead and read your options. That's
definition of congruent segments, definition of segment bisector. No. This congruent segment theorem.
It's C. In other words, we are told that E bisects BD. That's part of the given. Well, what does that tell us? That tells us that BE is equal to ED, right?
Yeah.
Because the definition of segment bisector. We are told that that segment is being bisected by E. Well, what does that mean? It means that it splits it into 2 equal parts, so BE has to be equal to ED. So the reason on number 3 is definition of segment bisector. Now it gets tricky. Notice that the 4th row, they don't give you either one. So let's look at the 5th row. The 5th row says that this triangle is congruent to that triangle. So what does the 4th row statement need to be?
CE equals CA.
Say that again.
AE equals CE.
We don't know that. They didn't tell us that E bisected AC. They told us that E bisected BD. Let's think about what we're going to need to prove statement 5. Notice what the very next statement is. The very next statement says this triangle is congruent to that triangle. Well, what do we have so far? We have that side's equal to that side, and we have that angle is equal to this angle.
So then A
has
to be equal to C.
Be congruent.
A to C.
Yes, but not directly. They never told us A was equal to C. We know
But isn't that needed to prove it?
Well, here's the proof that we would have to say. Because B is equal to D, then AB is parallel to CD by the parallel.
Oh, yeah.
Okay? And
Yeah.
because AB is parallel to CD, that makes angle A equal to angle C.
Okay.
So you'd have to state both of those things. And then you'd have congruence. Well, there's an easier way to prove congruence. Rather than going through and proving that AB is parallel to CD. What is true about that angle and that angle?
That they're equal.
Because?
Because of angle, or because vertex angles.
They're vertical angles.
Yeah.
Not vertex, but vertical angles. Okay, so if that angle is equal to that angle, that is all we need now to prove congruence. Because now we have angle, angle, side, or angle, side, angle. Right? If this is equal to that, then we have angle, side, angle equals angle, side, angle. So number 4 is not going to be angle A equals angle C, because we don't know that. But we do know that, let's see, 23 is the problem. And the answer is angle BEA, that one, is equal to angle DEC, this one. So that's the statement for number 4. What's the reason? Which is 24.
Just vertical angles theorem?
Correct. So that's 23 and 24. Now we can make the 5th statement, which is that this triangle is congruent to that triangle. And what's the reason? From 25.
Angle, side, angle.
Correct. Just always go in the straightest possible line you can. It's angle, side, angle. And finally, AB is congruent to CD. What's the reason for number 6?
AB to CB? Oh, they're parallels. Oh, or
they're congruent. Why are they congruent?
Well, we know the whole thing's congruent because they're equal, so it's TP, CTC.
Exactly. Corresponding parts of congruent triangles are congruent. And that's, if your test, your whole test is multiple choice, then any kind of 2-column proof is going to have to show itself like this, right?
Mm-hmm.
Have you seen problems like this ever? This is the first time I've seen it.
No, but I think that's the only way they could make it from a multiple choice.
I think so too. In other words, you're not going to have to do a 2-column proof except with multiple choice. And if it's with multiple choice, it's most likely going to look something like this. And this is kind of cool. I like doing 2-column proofs this way. It's not nearly as hard. All right, let's see. Let me get rid of that and go back to your pages. I guess you could say these are multiple choice. I still feel like it's going to be most beneficial for you to do these problems here.
Okay.
Let's go through some of these. Have we been through any of these at all?
No, we haven't.
Okay. So how do I do 40?
40, since the polygon's regular, you subtract, you find the number of sides, subtract 2, and multiply by 180 over n.
Perfect.
And that's how you get it. And then you can set that equation they give you to the number.
Okay. So how many sides do we have here? So this angle, you're saying, is equal to n minus 2 times 180 divided by n, right?
Yeah.
That's
Yes.
equal to 4x minus 21. Okay.
Yep.
What's n?
N is 8.
Okay. So we have 6 times 180 over 8 equals 4x minus 21. Relatively easy to solve for x.
Yeah, I can do that.
Okay. What's this figure called? 41.
A kite?
What's true about the interior angles of a kite? In other words, when I draw my kites, I like to draw them very elongated so that you cannot make a mistake. 1, 2, 3, 4. Which angles are equal?
2 and 4.
Only 2 and 4. And the
Yeah.
reason I do it elongated is notice that if I just make it like this, it's not real easy to see that 1 is not equal to 3. But if you draw it elongated, you can look at it and tell that 1 is not equal to 3. And also, it's pretty clear that 2 is equal to 4 if anything's equal. It's only 2 and 4. So, how am I going to solve? Each of these things are one of the angles. How can I solve for x?
Well, you can find the amount of degrees all the whole thing's going to be.
What's it going to be? How many?
4, 2 times 180 is 360.
Okay. So the sum of the 4 angles is equal to 360.
Yeah.
There's one angle, another angle, another angle. What's this angle down here?
That's 4x minus 9.
Okay, so what's my equation?
5x plus 11 plus 4x minus 9 times 2 plus 2x minus 8 equals 360.
Might be easier rather than, that's correct. But I would guess that it's probably easier to make a mistake doing it this way than if I did this. In other words, if I do it this way, I don't need any parentheses anywhere.
Okay.
In other words, I'm just taking angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. And you can do the algebra easy enough on that. But notice when you did 2 times 4x minus 9, now you got to distribute that. You got to get rid of the parentheses. You got to make sure it's minus 18. To me, it's easier to make a mistake doing it this way.
Okay.
Maybe not. I don't know. That's just my personal opinion. All right, 42.
Hmm.
Let's break this thing down. This is 15. This is 14. What's this dimension?
Which one?
One I've circled?
That is also 15.
Okay, and this dimension here?
14.
And this is 4x minus 8. What's that dimension?
Which one? B?
AC.
AC is 4x minus 8 plus b divided by 2.
at here? We're looking at similar triangles?
Yes.
In other words, because that is equal to that, in other words, because the line AC bisected DB and it bisected EB, by definition, it is parallel to this other base. In other words,
Okay.
I can now know that that line is parallel to that line.
Okay.
The fact that those are parallel makes it two similar triangles. I've got one triangle like that, and then I got the tiny one like that. Okay, this one's 15, 14. This one, what's this side here?
That side is also 15.
No, this is the big triangle.
Okay, so that's 30.
This side over here?
28.
What's the similarity ratio between those two triangles?
1/2.
I prefer to go big to little.
So 2/1.
Yeah, there's nothing wrong with 1/2. You can go little to big, and I know that your geometry teacher prefers little to big, but I'm pretty convinced big to little works better. You always want to work with numbers bigger than 1 if you have a choice rather than less than 1. I mean, if you're doing things like taking the square root of 1/2, would you rather take the square root of 1/2 or the square root of 4? You'd rather take the square root of 4. Most people know when you take the square root of a number bigger than 1, it gets smaller. What confuses a lot of people is if you take the square root of a number less than 1, it gets bigger. The square root of 1/4 is 1/2. Because that's confusing, don't deal with numbers less than 1 when you're dealing with similarity ratios. Always make it big to little. So in this case, it's 2-to-1. Okay? If it's 2-to-1, big to little, what is this side over here, this base right here?
It would be 2x minus 4.
They give us the perimeter of the little triangle is 39. How do I solve for x?
You could set the little triangle equal to 39.
Tell me the equation.
39 is equal to 15 plus 14 plus 2x minus 4.
Now, that's an answer. When you said set the little triangle equal to 39, I didn't know what that meant. What you meant was the three sides of the little triangle summed together equal 39. That I can write an equation for. And then you can solve that for x. Okay?
Yeah.
Most important thing in this problem was realizing that AC has to be parallel to ED. AC is called a midsegment. And it applies to both triangles and trapezoids. In other words, if I have a trapezoid, and I have a line that splits that side and splits that side, so that, you know, that's equal to that and that's equal to that, then this midsegment is parallel to both my bottom and top of a trapezoid, but mainly it's parallel to one of them, the bottom, and it makes these angles all the same. In other words, this angle is the same as that angle because they're parallel. Well, make it a triangle and it doesn't make it any different.
Okay.
In other words, the definition or the thing that makes it a midsegment, it also guarantees parallelness. In other words, as long as that line splits that side and splits this side, then it is parallel to the base. And because it's parallel to the base, now make this triangle similar to that triangle. And it's
Okay.
your similarity that allows you to solve this. If the little triangle was not similar to the big triangle, you'd have never been able to put that base of 2x minus 4 on AC. And you need that to solve the problem. You need to be able to define AC in terms of that number right there.
Okay.
I do find that a lot of these problems where you have similar triangles mixed together like this, to me, it really does help to split them out into two figures like that. Because now it's really easy to tell corresponding sides. You know, I know that this side here is the same as that side, or at least they're corresponding sides. That's corresponding with that, and that's corresponding with that. I can see it as long as they're separated. And I'm looking at two different triangles. When they're together, it requires a bit more imagination. Notice that angle B is common to both. So that has to be the same angle as that. And because they're parallel, that's the same as that. And this one is the same as this one. That makes the triangles similar. Now all you need is a similarity ratio. 43, what's that called?
43 is a parallelogram.
Okay, what's the relationship between those two angles?
They equal 180 degrees.
Good. So 3x plus 5x plus 20 equals 180. Easily solved. What can we do with 44? They want the perimeter, which means we're going to need to solve for x.
Okay. So the outside perimeter is 360 degrees.
No, perimeter is a scalar number. Some number of feet or something. It's not in degrees. But
well, the sum of the interior angles is equal to 180 degrees.
Okay, so what does that make this angle right here?
75 degrees.
So what kind of triangle is this?
Isosceles.
So now what equation can you write involving x's?
4x minus 11 is equal to 2x plus 9.
And that's going to let me solve for x. That means 2x equals 20, x equals 10. And once you have x solved for, now you can get the perimeter by just adding the three sides together.
Okay.
Okay?
Yeah.
Let's see. Are there any of these questions on this page? These blanks need to be filled in from these choices up here.
Yeah.
24 is kind of interesting. Let's just do 24. If I have an isosceles triangle, and the altitude from the vertex angle, you always make an altitude by dropping a perpendicular.
Okay.
Well, what else is that altitude? It's also what? It happens to be two other things from that list. In addition to being an altitude, what else is it?
It's a angle bisector.
Okay, this angle is equal to that angle, that's correct. It's also a median. Now, typically, a median goes from the vertex to the middle of the other side. That is a median. But
Okay.
only in an isosceles triangle does the median form a right angle. And the median is also the altitude in an isosceles triangle. In other words, if I take this triangle and I drop an altitude, I'm dropping it straight down to form a right angle. And so
Okay.
this is the altitude, this is the median, and they're not the same. But in our isosceles triangle, they are the same. They are one and the same. The altitude is the same as the median, and it's the same as the angle bisector.
Okay.
The rest of these are pretty easy. I don't think you'll have any trouble with any of them. Mark, good luck on your test tomorrow.
All right. Thank you, David.
Have a Merry Christmas, Happy Holidays, and I will probably talk to you next year.
All right. Thank you.
You're welcome. Bye-bye.